So in this question we have to find out how many distinct triangles can be formed with integral sides and perimeter equal to 14. Now integral sides means the measure of the length of the side should be an integer, should be a natural number of that triangle. But perimeter is fixed at 14. So friends, we know that the sum of any two sides of a triangle has to be greater than the third side. It also cannot be equal to, it has to be greater than the third side. And by using this, we can solve this question. So let's say A, B and C are the three sides such that the sum of A, B and C, which is the perimeter, is 14. So let us start counting how many triangles we can form. Let's assume that C is the longest side. Can we keep the value of C as 7? If we keep value of C as 7, then A plus B should also result in 7 as perimeter is 14. So if A plus B is resulting in 7 and C is 7, we'll find that A plus B is equal to C, and that therefore it is not possible because A plus B has to be greater than C. Sum of two sides, any two sides, has to be greater than the length of the third side for a triangle to be a valid triangle. So let us take now the length of the longest side as 6. Obviously it cannot be 8, it can only go downwards. So if we take this as 6, we have to get the sum of A and B as 8. So that 8 plus 6 results in 14. So in how many ways we can get A plus B as 8? So let's try with 2, 6. 1, 7 also results in 8, but then 1, 7 will make B as the longest side. Our assumption is C is the longest side, and moreover with 7 no triangles are possible. So 2, 6, 6 is a possible combination. 3, 5, 6 is also a possible combination. Remember 6 is constant for C and we are only changing A and B, so that the sum of A and B results in 8, and 4 and 4 also results in 8, and 4 plus 6 is 14. So all these sums results in 14. So with longest side being 6, we have got 3 triangles. Now let us consider the longest side as 5, 1 less than 6, and therefore the sum of A and B should be 9. So that 9 plus 5 again results in 14. In how many ways we can get 9? 1, 8, 2, 7 are out of question. 3, 6 is possible. So 3, 6, 5 we can write. But then it will not be a unique triangle because we have already counted 3, 5, 6. 3, 6, 5 will only change the order in which we look at sides, but it will not result in a unique triangle. Unique triangle means 3 sides different from the triangle that we have already counted. So 3, 6, 5 is out of question. Next comes 4, 5, and that is another unique triangle. 4, 5, 5 is a possibility, and after that we don't have any triangle with the longest side being 5. If you go on to do this, you'll realize that with longest side as 4, we have no unique triangle, because for this to be 4, A and B should be 10, and A and B cannot be 10 unless and until we repeat one of these countings that we have already done earlier. So friends, from here on we cannot find a unique triangle with perimeter 14 and length of sides an integer. So the answer of this question is 4.